Again, happy Tuesday. Happy Tuesday. Only those of you that just got here, there are only a few more days left of school. 4 days this week and 5 days next week. Grades are due next Thursday. All teachers turn in their final grades next Thursday night. Unless you're a senior, we turn it in this Friday. We turn in, and yes, they can change. Yes, they can change after. So like this Friday, if you're a senior and we put a grade and you need it changed, it can be changed. It can be changed up until graduation. But everyone else, I turn it in on the 10th. And yes, that Friday we can change it, but most likely we're not. Just turn in all your work before Thursday. Next Thursday, yes, is when we turn grades. Let me show you. Right? So we're right here. June 1st. Happy June. Rabbit, rabbit, right? Some people say rabbit, rabbit at the beginning of a month for good luck. I don't know. So here we are, June 1st. So here, final grades are due, and here's the last day of school. Okay, we turn it in that night. So you have until this day to turn in anything. I would turn in everything that you have late this week, just to be safe. Just turn in everything you have this week. Okay. All right, so let's go back. Okay, identify as many parts as you can. So anyone, just shout it out or put it in the chat. What do you see here that you can identify? It's a whole bunch of stuff here. Anybody? Radius. What's a radius? There's three of them actually. So yes, there is a radius here. Which one? So what? Segment KI. Yep, that's a radius. What else? Anyone else? JK. Are you kidding or you mean it? That's a radius. And LK. That's a radius. Good. Anyone else? KL. Very good. Very good. Anyone else see another part here that they can identify? Well, what about the circle? What's the circle? This is what? Circle what? Circle K. Very good. Hey, Circle K. You can buy, you can get gas and buy some refreshments and stuff. Circle K. So we would say, because the reason we call it K, because K is the center. Very good. And then someone said, pretty sure JLI is a semicircle. So here we go. So from here, arc JLI is a semicircle. Right? Because it's half the circle, right? And if that's a semicircle, then from here to here would be a what? Because it goes through the center. It goes all the way across the circle through the center. JI would be a what? JI would be a what? A diameter. Very good. And a diameter is 2 radii. Okay. Anyone see anything else? There's a lot of other stuff here too. Anything else? Come on, guys. Everyone, I'm getting the same people answering. Everyone, come on. Wake up. Wake up. Wake up. In 2 weeks, you will be in summer vacation. So let's continue to work. School's not over yet. Is there a major arc? Which one? What gave me a major arc? I and L. So like this way. So going like this. Going all the way around till you get to here. So that would be a major arc. And we would probably call it IA HL, or you can call it IJL. You just need 3 points that's on that arc, right? JK is a radius? Yes, JK is a radius. JK is a radius. And if you want to look at this again, guys, because I know sometimes Zoom can be blurry. This will be put up on YouTube today. Okay. JG is a tangent. Let's see. JG is a tangent. Very good. So this segment right here is a tangent because it touches the circle at 1 point. And that point that it touches is the point of tangency. Right? Wherever the tangent touches the circle, that's your point of tangency. Right? Anything else? Anyone want to tell me what GI is? What is GI? From here to here. What is that? What's GI, guys? GJ is a... Yes, GI is a secant. Very good. That's a secant segment. And remember, secants can be segments or secants can be lines, right? They don't have to go all the way through. And someone said, what about... someone said this earlier. Who said that earlier? Someone said in the chat earlier, what about the minor arc? Yeah, we have a few minor arcs, right? That's a minor arc right there. So we can even like make a little list if we want to. Right, we have a minor arc at arc JH. That's a minor arc. What about this one right here? HI. HI is a minor arc. And remember, minor arcs only have 2 points. We also have a minor arc JL. We also have a minor arc IL. We also have an angle. What about this angle right here? What can we call this angle right here? Oh, JL is a chord. Very good. JL. That's a chord. What would we call this angle right here? Oops. What would we call that angle right there? It's an angle that's in the center. An angle that's in the center. I wonder what that could be called. A central angle. Very good. That is a central angle. And what would we call this angle right here? What would we call this angle right there? What's that angle? What's that angle called? That angle is not a central angle because it's not in the center, but it is inside the circle. It's on the circle. So remember, there's 2 kinds of angles inside the circle. There's a circle that's in the center called the central angle, and then there's another angle that's on the side or the actual circle, not the center, and we call that a what kind of angle? Inscribed angle. Very good. Okay, does anyone notice anything else? Yes, someone said, Mister, isn't that an inscribed angle too? Yep. And isn't that an inscribed angle too? Yep. So just to let you know right now, we just did part of your homework. Okay, so your homework that is due on Thursday, this is the first part of it. There's pieces that you're going to have to identify, but it looks like you did a great job at identifying a whole bunch of pieces. So is there anything else we missed? Anything else we missed before we move on to our new topic? Anybody? All right, I think we've got pretty much everything. All the arcs, the major arcs, the minor arcs, the semicircles. Oh, this is also a semicircle, right? If from here to here is a semicircle, then that means from here to here is also a semicircle. So JHI is also a semicircle because it's half the circle. All right, I think that's pretty good. All right, so just to let you know. Oh, someone said, Mister, can you do this up for a minute? Okay. Yeah, and it's probably a little blurry. If you want me to zoom in on a certain part, I can, because I know, again, zoom is blurry. If you want me to zoom in on a certain part, but this will be on the YouTube video that I will upload after the class. And it does take a while for it to process the HD version. So probably by the end of the school day, it will be up and clear. Okay, so let me show you. So what happened? There it is. So if you go to Schoology and you log in, Mister, you show us this all the time. Yes, because there are people who don't pay attention. I know, shocking, right? So go to our course, period 11, click on that, and you will see week 20. Yes, look at all this. Look at all these weeks. These are all the weeks from this quarter, just from this quarter, right? And we're on week 20. Click on week 20. And next week is what? Next week is week
21.
Yes, next week is week 21. So this is week 20. And you'll see here we have notes, area and circumference of circles, notes. It's not an assignment. I got to repeat this every time because I still have people turning in notes as an assignment. It is not an assignment. The only reason I put it as an assignment is because when you click on it, and if you're on Chrome, right here next to view, it should say open in Kami. And I know some of you like to use Kami for your notes. So that's why I did that. Okay, and then you have this area and circumference notes solutions. So all the solutions to our notes are here. So if you miss something or if we don't do a problem, it's all here. See, we don't, there's like what? There's 20 samples here. We never do all these samples on our notes. So if you ever want to practice and go into the notes and try a problem, see if you're correct, it's all here. So there's your note solutions. And lastly, the homework is here. It's due on Thursday. The homework is there. And if you look at the homework, this first part, the top part, this top part is what we just did. So we just did some of your homework. All right, so everyone get your notes. Get your notes ready. It's in here. Whatever you do, you print it out, you put it on Kami, you write it on a regular piece of paper. However you do it, just get it. I'll give you a minute to take it out. And it should look like this. Okay, so I'll give you a minute. I'll give you some background music to get your notes by. There we go. Get your notes, get your notes, get your notes, get your notes ready, get them ready. There you go. There is your get your notes music. All right, so now we're going to be talking about area and circumference of a circle. Okay? Area, you should all know what area means. Area is the stuff inside, right? And the other word that you usually hear is perimeter, right? Perimeter is the distance on the outside of a polygon, right? While circles are a little different, we don't call that perimeter, we call it circumference. And circumference is just the distance around. So right here you can put circumference means, and I know it's a long name, circumference is the distance Oh my God, I can't write. Distance around the circle. And the area is inside the circle. How many squares can you fit inside the circle, right? Like a play area. When I say that's the play area, you don't just stay on the edges. You play inside the area, right? So that's what the area is. If I ask you to stay on the perimeter or the circumference of a circle, you're just going to stay on the outside. So there are some formulas. Now I could sit here and derive. What does that mean, mister? I can derive the formulas. That means I can show you where they come from, because a lot of you think formulas just come out of magic, that someone just came up and said, hey, this is the formula. No, it doesn't come from magic. It comes from patterns, right? You can invent your own formula if you want to. There's some stuff out there in math that still haven't been solved. Look it up. And there's money out there if you can solve it and come up with a formula. So formulas come from patterns. That's scary. What's scary? What's scary? That there's formulas are not scary. They come from patterns, right? Right? They come from patterns. Like multiplication is kind of a formula just for adding. Like someone in a long, long time ago was saying 3 plus 3. Like, so a long time ago, they were like, 3 plus 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 3 plus. This is taking a long time. And a lot of times formulas come from stuff takes a long time to figure out. There's got to be a better way. Those are like the infomercials of the old times. Way, way, way back. Do you hate adding a bunch of numbers that are the same? Yes. Well, here's something new. I wish my life was easier. Now it's called multiplication. Instead of saying 3 plus 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 3, you just say 3 times 9, and you get the same answer. Wow, that's so much easier, right? That kind of stuff. Multiplication is just a formula of repeated addition, right? So that's all formulas are. Something that's taking a long time to do, is there an easier way? And if we had time, I would derive the area and circumference formula. I would show you exactly where they come from, but we do not have a lot of time. So I will just give you the formulas, okay? First thing you need to know, though, is when they started looking into circles, right, they noticed something happened every time, right? Something happened every time. Every time, right? Every time they would look at the circumference and the diameter of a circle, every time they got the circumference and they divided it by the diameter, they always got the same number, no matter what the circle was. They got a bunch of circles. They got tiny circles. They got huge circles. They got medium circles. And they measured the diameter. They just measured how far this was. And then they measured the diameter. So they measured the circumference and they measured the diameter. And then they divided circumference by diameter. And they always got the same number. Does anyone know what that number is? Like this ratio that they did, they kept saying, okay, they got huge circles, and they measured the distance around the circle, the circumference, and they measured the diameter, and every time they made this ratio, they got this number. Right? They got the same number every time. 3.1415926 ... went on forever, did not repeat. And since they saw this number, this relationship between the circumference and the diameter, they said, oh, this is the same for every circle. So let's give it a name. So they gave it a name, and they gave it a letter, right? They gave it a letter. You know what letter they gave them? It's not our letter. It's a letter from a different language. They gave the letter pi. Right? So they said this is pi. So since circumference over diameter was always 3.14159, instead of writing this whole thing, they just wrote the letter pi. And so that means circumference over diameter equals this number pi, which is 3.14, 3.14 for short. If you just multiply both sides by d, this cancels. Circumference equals pi times diameter. I know I told you I wasn't going to show you where it came from, but that's where circumference came from. Circumference just equals that number pi, which is the ratio that all circles have, times that diameter. But mister, yeah, isn't diameter 2 radii? Yes, it is. So can I replace it? Yes, you can. So you can also say the circumference equals pi. And what is diameter? Diameter, isn't that 2 radiuses or 2 radii? Right? And so we can say circumference also equals 2. We'll put 2 in the front, and then we'll put pi, and then we'll put r. So someone asked in the chat, do we write that? I mean, if you want to remember this, yes, that's the formula. Circumference formula is pi times diameter, or a different way is we can say 2 pi r. Okay, because a diameter is the same thing as 2r, 2 radii. So there's your 2 formulas, circumference formulas. If you have the diameter, then you use this formula. If you have the radius, you just double the radius and still multiply. So this 2r is still the diameter. You still multiply by pi. So there's 2 ways to look at it. Same formula, just 2 ways to look at it. And so that's circumference. And you should have done this in middle school. You should have, measured, your teacher should have had you measure a bunch of circles, their circumferences and their diameters, and then make a ratio and put in your calculator, and then you would see every time, hey, no matter what circle it is, we still get the same ratio, which is pi, 3.1. And we say 3.14 or 22 over 7. Those are the 2 common. So pi is usually 3.14 for short, or 22 over 7 for short. Okay, so that's the circumference formula. What's the area formula? So the area of a circle is pi times radius squared. Okay, so area equals pi r squared. Okay, so there's your 2 formulas. There's your 2 formulas. Write it down. If you forget it, you can look back at your notes. They're right here. Yes, you do write this down. These are your notes. This is the name of the topic, right? Area and circumference of circles. So yes, you definitely need the area and circumference formulas. So I'll give you a minute to write that down. Yes, you have a question. Don't unmute yourself because I am recording. I'll give you a minute to type it in. And if anyone else has a question, you can also type it in. Yes, because as I explained before, the question was, are these 2 formulas the same? As I explained before, diameter is the same thing as 2 radii. That's all. So this formula is written with diameter. This formula is written with radius. I just happen to rearrange. I put the 2 in the front and the radius at the end and pi in the middle. But yeah, diameter is just 2 radii. Yes, so they are exactly the same. Just looking at it two different ways. One with the diameter, one with the radius. Great question. Great question. Yes, because again, if I had a circle, right, and I knew that the diameter was 10, that means the radius is 5. It's the same thing, right? So circumference equals pi times diameter, which is 10, or circumference equals 2 pi radius, which is 5. This would be 10 pi, and this would be 10 pi, right? Because, again, diameter is 2 radii. So you're either going to put a 10 right here because that's a diameter, or you're going to put a 5 right here because that's the radius. And it's just, there's your 2 to double it. Yes, so you'll get the same answer. All right, that's it. There's your lesson, guys. That's your lesson. Just know the formulas. You just know the formulas, and we're going to use those formulas to find area and circumference, and sometimes we're going to use both. That's when it gets a little trickier. But today, we're just going to do area and circumference of some circles. Okay? And you can get an actual number if you want to. You can make pi 3.14 or 22/7 to approximate, or you can use the pi button on your calculator. If you look on your calculator, there should be a pi button. You guys see it? And so if you use the pi button on your calculator, that'll get you a more accurate number. That'll get you a more accurate number than if you just use 3.14 or 22/7. But I mean, we're not scientists here. We're not trying to get super accurate. We're not sending a rover into space or anything, or a satellite into space where we have to be super accurate. We're a high school geometry class. We can be kind of accurate. Okay, so here's what I mean. So if we look here, for number 1 through 4, find the area for 1 through 4. So find the area for 1 through 4, and find the circumference for 5 through 8. So let's look at number 1. The area would be pi r squared, right? That's the formula, pi r squared. So the area would be pi, which is 3.14, times radius, which is 12, and we square that. And so we get our handy dandy calculator. And we first, what do we do first? Yes, very good. We square this first. So that's 144. And then we multiply by 3.14. And so our answer is 452.16, and we say meters squared, right? Because you also square the units, right? You know how we're squaring the radius? We also square the units, so it's meters squared. So it's square meters that we can fit in there. That's using 3.14. If I used pi, right? If I did this and I used my pi button, let's see what big of a difference it would have made. Okay, so if you look on your calculator, there should be a pi button. Right? You'll see it. If you have an iPhone, you'll see it. There's a pi button. So if I put 144 and then I click pi, I put 144 times, and then I hit the pi button, and I hit equals, I get 452.3893421169302. So it's a little different. You see that? Because pi is not 3.14. That's approximately what pi is. But if I use the real pi, like the pi button on my calculator, I get a little. Now, if we notice, it's still about 452 meters squared, right? Still pretty close. Still pretty close. But this is more accurate if you use the pi button. So if you guys are like, I want to be super accurate, then go ahead and use your pi button. If you want to be like, hey, I'm okay with not being 100% accurate, then go ahead and just use 3.14. Okay? You see the difference. It's not too big of a difference. This is 452.16. This is 452.38. If we're launching something into space, that's huge. That's a huge difference. We can't make that mistake. But since we're in a high school geometry class, I'm okay with either one. If you just want to use 3.14 to make your life simple, that's fine. If you want to use the pi button to get more accurate, because I want to be accurate, mister, that's fine with me too. Does that make sense? Everyone good with that? Why don't we try landing one? I would be up for that, but we'd have to learn a lot more stuff. And I think we'd have to get clearance from the FAA to launch something into or out of the atmosphere. Yeah, I think we'd have to get some permissions and we might need a couple of permits. I'm just telling you, if you really, I'm not seriously going to do it, but I'm saying if you really wanted to launch something, there'd probably be some permits involved. You'd probably have to talk to government people, let them know. A license for space. Yeah, you have to. The FAA controls the what flies in the air, right? All right. So that's area. So go ahead and try one. I want you to try number 2. Try number 2. Find the area. Find the area for number 2. Give you a couple of minutes. So try number 2. Find the area of that circle. 2, 1. Okay, time is up. So if we remember, if you forgot, look up here. The area formula for a circle is pi r squared. So area is pi r squared. And if you look here, we have the diameter. The diameter is 18 inches, but I don't want the diameter. That's not part of the formula. I want the radius. So the radius is 9 inches. So my area is pi times 9 squared. So the area is 81 pi. Now, some teachers, and sometimes me too, if you want to keep it like this, 81 pi inches squared, that's fine. That's fine. You can leave it like that. But if we need an actual number, then we have to punch into our calculator. So we can punch into our calculator. We can use 81 times 3.14. And we get 81 times 3.14. And we get the area is 254.34 inches squared. That's one way to do it. Or we can say 81 times pi, right, in our calculator. So we say 81 times, and then hit the pi button and hit equals. And we get area equals 254.46900494077733 inches squared. Okay. So if you gave me this answer, I'm okay with that, right? 81 pi inches squared. If you want to just keep the pi as pi, a lot of people do that. That's fine. You're going to do that in trigonometry. You're going to do that a lot. Keep it like this. If you want an actual number, then you can punch in 3.14 and get 254.34. Or if you want to get more accurate, you can put in the pi button on your calculator and get a more accurate answer. Okay, does that make sense? Does that make sense to everybody? All right, you can start on your homework tonight. I would. It's due on Thursday, so I would start on my homework tonight if I were you. You don't have to finish it. Just get started. Do a few problems. And that's it for today. If you have any questions, let me know now or let me know on Schoology at any time during the day. And I will see you all tomorrow. Have a great Tuesday, guys. Take care.